आपका पहला सुपर टीचर कौन था?
आई, मबो,
मम्मी,
ताई,
माँ,
माई,
मोजी।
माझी आवय,
मॉम।
इस मदर्स डे अपने पहले सुपर टीचर की शान बढ़ाओ और सरकारी नौकरी घर लाओ। जी हाँ, टेस्टबुक सुपर कोचिंग लाया है एक अमेजिंग ऑफर जहां आपको मिल रहा है 20% का एक्स्ट्रा डिस्काउंट और 33% की एक्स्ट्रा वैलिडिटी सिर्फ और सिर्फ इस 13, 14 और 15 मई को। इतना ही नहीं, अब आप जीत सकते हैं एक स्मार्टफोन सुपर कोचिंग की तरफ से और दे सकते हैं अपनी माँ को एक तोहफा। तो अगर आप स्क्रीन पे दिए गए एग्जाम्स की तैयारी कर रहे हैं, तुरंत जाइए और टेस्टबुक सुपर कोचिंग में एनरोल करिए। देश की सभी माँओं को मदर्स डे की हार्दिक शुभकामनाएं।
Hi, good evening, everyone. This is Shefali Singla, and in the session, we are going to discuss the concept of decomposition of a relation. So, as we know that this is a basic of RDBMS because whenever we find redundancy or duplication in the database, we have to eliminate it. For that, we sometimes need to decompose the relation into sub-relations, okay? But there are few properties for the decomposition because we don't want to lose any property or any data after the decomposition. So how to check that, or on what basis the decomposition will take place? What are the properties of decomposition, and when can we say that the decomposition is correct? We'll be getting the answers for all the questions in this session, okay? So sometimes very straightforward questions, or you can say the direct questions, can also be asked on the basis of the decomposition. Like we have two properties for the decomposition. One is check whether the decomposition is lossy or lossless. Other one is to check whether the decomposition is dependency preserved or not. So आपको relation given होगा and you have to identify that which of the property satisfies. So on the basis of this you'll be getting four options. Given decomposition is lossy but dependency preserving, lossy but not dependency preserving, lossless, dependency preserving, like that. Okay, so these are the three different types of questions that can be asked on the basis of decomposition. And if we talk about the application of decomposition or the usage of decomposition in depth, so that will be covering under the normalization, because normalization is basically used to find out the redundancy at what level the redundancy is there, and we have to eliminate it by decomposing the relation. So on the basis of that, you can expect a question like, you will be given with some relation and the functional dependency set, and it will be given in the question that if the relation has to be in 3NF, then the given relation will be decomposed into how many sub-relations. So this can be like the multiple choice question or the numerical answer type question. So you have to find out the number of decomposition. तो वहाँ पे भी हम ये दोनों properties use करेंगे. So that's why this topic is going to behave as work as a basic for the normalization. Okay. So let's start with the properties of a decomposition. Can somebody tell me that what are the properties of a decomposition, or when can we say that the decomposition of a relation is correct? So there are two properties. Decomposition is said to be correct. Decomposition is said to be correct if and only if it is lossless decomposition, it is lossless join decomposition, and dependency preserving decomposition. So what do you understand by the term lossless joint decomposition? Obviously, you can take out the literal meaning of the words that I have written here. Very good morning, very good evening, Shubham. So, what is this lossless join? What do you understand by lossless join? Can you make a guess? अगर आपको term नहीं पता, then also you can easily make a guess over it. This simply says that, see, when we are dividing a bigger relation, let's assume that there is a relation R and we are dividing this relation R into the sub-relations. Let me call this as R1 and R2. Okay, so decompose का मतलब कि let's assume that here we have the attributes like A, B, C, D. So I want to divide this relation into the subparts. For example, here we have the attributes like A, C, D, and here we have the attributes like B, C. Okay, so the relation is divided into the sub relations. अब हम ये बोल रहे हैं कि जो हमारे पास data है that is available in the sub relations. But at some point of time or when we are executing a query, there may be a necessity of joining the relation. कई बार क्या होता है relation को join करने के बाद हमें query का result मिलता है, right? So for that we need to join this relation. So lossless join decomposition means when we are joining the relation, in that case, there is no loss of data. No loss of data means no existing data should be lost or no new data should be produced. So after joining the relation, we should get the original relation R with the same number of tuples. Okay. So this is lossless join decomposition. Dependency preserving, this is just an overview. We will be understanding all both the properties with the help of the examples and the questions. Okay. Second one is dependency preserving decomposition. नाम से ही समझ में आ रहा है, dependency preserving means whatever functional dependencies are given for the relation R, whatever functional dependencies exist for the relation R, all those functional dependencies will be preserved, or all those functional dependencies will be supported by the sub-relations as well. If all the functional dependencies are supported, then we will say that the given decomposition is dependency preserving because it is preserving all the existing dependencies. Make sense? इतना clear हुआ? Yes. So let's write here the definition for lossless join decomposition. This simply says that let R be the relational schema decomposed into subrelations. Decomposed means divided into subrelations R1 and R2. R1 and R2. Or let's take the general definition. Let us assume that it is divided into n subrelations. Divided into subrelations R1, R2, and R3, and so on up to Rn. Okay, so in general, we want to say that, in general, I want to say that after joining all these subrelations, R1 join R2, अगर इन सारे subrelations को join करते हैं, then we should get, this was R3. This way we have to join all the subrelations R3 and going till Rn. So this will either be greater than or equal. So we say that greater than or equal to R. ये हो सकता है, but let me write here because I don't have much space there. So if यहाँ पे दो properties आई, join करने के बाद it might be producing the extra tuples or it might be producing the exact same number of tuples. दो options है, अगर extra tuples आ रहे हैं, that means it is lossy decomposition. It is not returning the original relation R, so this is known as lossy decomposition. You get this point? And if it is producing the same number of tuples as present in the relation R, then it is known as lossless joint decomposition because it is returning the exact relation R. So this is known as lossless. Is this clear? Now, in one batch, somebody asked me a question that why we are joining the relations on the basis of the key attribute, or why are we taking common attribute. That time I told you that, guys, I'll be taking a session specifically on decomposition of a relation. At that point of time, I'll give you the reason. So that's the time. So lossless joint decomposition के लिए, let us consider one example. I hope that the definition is clear to everyone. Let's quickly give me the confirmation. Quickly give me a confirmation if it's clear till this point. All right. Thank you, Gautam, for the confirmation. So lossless joint decomposition. Let us consider one relation R. This is the relation R with the three attributes. मैं बहुत छोटा सा relation ले रही हूँ just to understand the rules to check whether the decomposition is lossy or lossless. Exam में हम पूरा process follow नहीं करते. I'll simply tell you that what steps we need to follow. There are 2 to 3 steps and that will be sufficient. So relation R is there with the three attributes, and let us assume that the data is, although for decomposition or for normalization we perform till 3NF or BCNF, no data is required. I'm just considering the data only for the understanding purpose. In the exam it is not required because I want to give you a reason, so that's why I'm considering the data. Okay, so this is the relation R with three attributes, and let us assume that the data is 1 2 3. This is having 1 1 2, okay, and 2 1 2. Let us assume that this is the relation, and this relation R is decomposed into two sub-relations, R1 and R2. Okay, here in this case I'm considering A and B, and here we have the attributes B and C. Now, first question arises is, why am I taking this common attribute? When the reason for this is, when we have to perform the join करने के लिए there should be some common attributes, or randomly I have taken B as the common attribute. Okay. How this join operator works, let us understand that. जिन लोगों को clear नहीं है. So if I want to perform R1 join R2. Join operator work कैसे करता है? First of all, we need to take the cross product of R1 and R2. After that, we need to perform the selection. That means here we have to apply the condition where natural join करते हैं तो जो भी common attribute होगा, for that the values should be same. And after that, we will be projecting the columns, okay, unique columns. So here in these two relations, common attribute is B. So R1 में भी attribute B आ रहा है, R2 में भी attribute B आ रहा है. Since दोनों की value same होनी चाहिए, so we can drop it out. So this is why we need to take the common attribute. Now question arises is, what should be the common attribute? Common attribute A भी ले सकते थे, B भी ले सकते थे, C भी ले सकते थे. Which common attribute will be giving you the correct answer? We have to focus on that point. मैंने आपको बताया था कि if we are taking the key attribute as the common attribute, then the decomposition will be lossless. Okay, अगर आप नॉन की एट्रीब्यूट लेते हो, नॉन की का मतलब क्या होता है? Redundancy is allowed. That attribute can have the same value. For example, I'm considering here B as the common attribute, और ये जो attribute B है, this is not a key attribute क्योंकि key के अंदर आपके पास same values, duplicate values नहीं आती हैं, but here we have the duplicate values. So in this case, I'm considering the non-key as the common attribute, and I'll be considering one more case in which I'll be taking A as the common attribute. ये clear हुआ? Let me write here just to understand the difference. we have the attributes ABC with the data ABC, and data was 1, 2, 3, 1, 1, 2, 2, 1, 2. Now I'm decomposing this relation into some relations R1 and R2. Now I'm going to consider A as the common attribute. What is this A? A is now a key attribute. Make sense? So here we'll be having the data for R1. This is 1, 2, 3, 1, 1, 2. In R2, we have two attributes, A and C. Data is 1, 2, 3, 2, 1, 2. Here we have the data. Are you all getting this point? Same क्वेश्चन को एक बार हम की के बेसिस पे ज्वाइन करेंगे, सेकेंड केस में हम लोग नॉन की के बेसिस पे ज्वाइन करेंगे, एंड दैट विल गिव यू द क्लैरिटी फॉर द रूल्स ऑफ लॉसी और लॉसलेस decomposition. Okay, so here we have the attributes AB, and here we have the attributes B and C. Common attribute is key 1, 2, 3, 2, 1, 2. Okay, so first of all, let's perform the join. What is the first step? Step 1 is to take the cross product of R1 and R2. Cross product क्या बोलते हैं? Cross product में जितने भी आपके पास tuples हैं, all the tuples will be joined with the, or we are going to take the combination of all the tuples with the other relations tuples. Okay, and we'll be having all the attributes. So step 1 is I want to perform the cross product on R1 and R2. So here we'll be getting four attributes, R1 dot A, R2 dot B, R1 dot B, and then R2 में भी आपके पास B and C है, R2 dot B and R2 dot C. These are the four attributes for the cross product. Now what we need to do is we need to take the combination of each tuple with every other tuple of R2. So 1, 1. Here we have 1 and 1, and its combination will be taken with 1 and 2. I'm taking its combination with all the tuples of R2. This is what I'm going to write now. Okay, so this is 1, 1, and value is 1, 1. Here we get 1, 1, and value is 2, 2. Are you all getting what I'm doing? So first row का मैंने combination सबके साथ लिया, then same will be performing with second tuple of R1. So this is 2, 1, 2, 1. बच्चे मुझे step by step confirmation देनी है, because at the end if you'll be like repeat again, then it's going to be difficult. Okay, difficult नहीं है. The main thing is we'll be wasting our time, so it's of no use. I guess it's going behind the image, so let's manage the space. Two, 1, and 2, 2 we have 3, 2, 3, 2, 3, 2. Now is it clear? 1, 2. So what I have done here is I have taken the cross product. This is step 1. Okay? This is step 1. We have taken the cross product. Step 2 is saying that we have to select the rows where the value of the attribute B is same. Value of B is same. Yes, this row will be selected. Value of B is same. This row will also be selected. Value of B, R1 dot B is equal to R2 dot B. No, this is not same. So we'll be discarding this row. Value is same. Value is same. Value is not same. Value is not same. And this is selected. So basically, 5 tuples are selected. So let me write down the result for the step 2. Step 2 का result आया. So here we are getting R1 dot A, R1 dot B, R2 dot B, and R2 dot C. So this is the result we are getting after performing the selection operator. Selection क्या कहते हैं? Row के ऊपर condition apply करते हैं. So 5 rows are returned here. Yes. So data is 11112. 4 times 1 we are getting. Then is 2112. Then is 2111. Then is 322. Now, if you observe the value for the attribute r1.b and r2.b is same, so we are going to project the distinct columns. So distinct column means r1, these values are same, so we can discard one of the attribute and r2.c. So after projecting, after the projection, this is step 3 now, this is going to return A, B, C. What are the values? Basically, here it is going to return 5 tuples. जबकि original relation में कितने tuples थे? There were only 3 tuples were there. 1, 1, 2, 2, 3. 1, 1, 1, 1, 2, 2, 1, 2, 1, 2. So this is the final result that we are getting after joining R1 and R2. Is it equal to R? In the R we had 3 tuples, and after joining these sub-relations we are getting 5 tuples. That means it is producing some extra data, some extra tuples are produced. So we can say that the given decomposition is, this is the lossy decomposition. It is not returning the exact relation. Is this clear? ये कौन सा केस था? When the join was performed on the basis of non-key attribute. B was a non-key attribute. Here the common attribute, this is case 1, common attribute was a non-key attribute, hence it is returning the lossy decomposition. ये clear हुआ? Now in the second case I am going to consider common attribute as the key attribute. Now here the common attribute is the key attribute. A is a key attribute according to the instance that we have considered. Obviously, A is a key attribute. ये clear हुआ? I'll be performing the same steps. Okay, so first of all, we have to perform the cross product on R1 and R2. R1 cross product R2. Here we'll be getting 4 R2 dot B, R1 dot B, R2 dot A, and R2 dot C, right? All the 4 attributes are coming up. Now take the possible combinations. It's 1, 1, 1, 2, 1, 1, 2, 1, 1, 1, 3, 2. Take the next one, 2, 1, 1, 2, 2, 1, 3, 2. Then next is 3, 2, 1, 2, 2, 1, and 3, 2. Okay, so this is the result after uh, taking the cross product. Second step is to apply the condition. Condition will be always be applied on the common attribute. So in both the relations, common attribute is A. Just check the value. Value is same. Yes, so this row will be selected. Let's write down the result here. Guys, anyone facing any problem? So after this, I'm just going to conclude the concept. R1 dot A, R1 dot B, R2 dot A, R2 dot C. So here, first row will be selected. So let's write down the result. It will be a 111, 2. Value of attribute A is same? No. So this will not be taken. Value of A is same? No. This won't be taken. Value of A is same? No. This won't be taken. So basically what we are looking for, we are looking for the value of the attribute A. If it is same, then we'll be selecting that. Next one is value of A is not same. Value of A is not same. Value of A is not same. Value of A is same, so this will be taken. Okay. Now, if you observe the first and the third column, that is for the attribute A, third step is to apply the projection. We have to project A, B, C from step 2. मैं पूरा step नहीं लिख रही हूँ. So here that is going to return A, B, C. Attributes are A, B, C. Values are 1, 2, 3. 1, 1, 2, and for C this is 2, 1, 2. Are we getting the same relation? Yes, exactly, we are getting the same relation. So we can say that when the decomposition is done on the basis of the key attribute, then it is lossless. Lossless means there is no extra tuple is produced. So it is going to return lossless join decomposition. Make sense? तो इसलिए जब भी हम steps perform करवाते हैं to check whether the relation is lossy or lossless, what we need to do is, first of all the attributes should be covered in the subrelations. There should always be common attribute, because if there is no common attribute, we won't be able to join the subrelations. And third case is, whatever is the common attribute, that should be the key attribute. This is the conclusion. And here is the example for both the cases. मैंने दोनों cases लिए, एक में हमने key attribute, common attribute लिए, and the other case I have taken the non-key attribute as the common attribute. So quickly give me the confirmation if it is clear. Hurry up, guys. No response. How will you solve the questions then? Come on, hurry up. Okay. First of all, please focus on understanding the concepts, because I have already discussed with you guys many times that I have an official Telegram group, that is Shefali Ma'am Testbook. You can search for it, or directly you can join it through the link which is given in the description box of this video. And in this Telegram group, on the daily basis, I'm sharing the PDF of all the YouTube sessions. So you will get a set of questions, you will get the theory that I'm using. So everything will be posted in the group. So better is ki when you are attending any session, focus on just understanding the concepts, because there are a lot many resources from where you can get the notes or the theory. Okay. And next one is, in case you have any doubt or query, you can share that in the Telegram group. You can directly interact with me. You can participate in the quiz and the polls, so that you can keep track of your preparation. All right. So let's talk about the condition for lossy or lossless decomposition. Now only we have discussed the concept. So first of all, what should be the condition? So basically there are three conditions. First one is, uh, the decomposition should cover, or let's understand this in more detail. So let us assume that the relation R is decomposed into two sub-relations R1 and R2. मैं पहले छोटा वाला केस ले रही हूँ, R1 and R2. In that case, what we need to do is, step 1, R1 union R2, that means जब दोनों के attributes का union लोगे, it should result all the attributes of the relation R. कोई भी attribute missing नहीं होना चाहिए, because अगर कोई भी column drop हो गया, कोई भी attribute miss हो गया, तो definitely it won't be a lossless joint decomposition. So all the attributes should be covered. Second one is R1 intersection R2. What does it mean? That means when we are taking the intersection of the attributes of R1 and R2, there should be some common attribute. This should not be equal to 5. That means there should be should be some कॉमन एट्रीब्यूट, क्योंकि जब कॉमन एट्रीब्यूट होगा तभी हम ज्वाइन करवा सकते हैं, अदरवाइज ज्वाइन ऑपरेटर वोंट वर्क, so that's why it is mandatory to have some common attribute. Correct? Third condition. Now we have said that if the relation is joined on the basis of the non-key, we are getting the lossy decomposition. So this decomposition should be a key. Common attribute should be a key attribute. Common attribute. How to find out the keys? Common attribute should be key attribute, right? Key attribute कैसे find करते हैं? जो भी एट्रीब्यूट है R1 इंटरसेक्शन R2 का जो भी रिजल्ट आया है, की का मतलब क्या होता है? If we are taking the closure of any attribute and that is determining all the tuples of relation, so it's a key attribute. That means जो भी आपके पास common attribute आया है, इसका closure लेकर if I am able to identify R1 or if it is a key for closure later, after finding the closure, it is behaving as a key for R1 or it's behaving as a key for either of the relation, then we will say that the decomposition is lossless. Then we'll say that decomposition is lossless joint decomposition. Make sense? So this is the testing condition, and I'm repeating again. In the first step, we are looking for whether all the attributes of the relation are covered. सारे attributes सारे decompose होने के बाद भी second thing is there any common attribute? Because if no common attribute is there, then we won't be able to perform the join, and that common attribute should be the key attribute. That's it. Okay, so this already we have proved. This is case one. Sometimes the relation is decomposed. Second case, sometimes the relation R is decomposed into more than one subrelation like R1, R2, R3, and so on up to Rn. So what we need to do is we need to perform the join on all the subrelations, and at the end we want a single relation. So all these steps will be performed as it is. At any point of time you have to select two subrelations. So first step is after taking the union of all the subrelations, it should return, it should cover all the attributes of the relation R. सारे attributes cover होने चाहिए. Second step is at any point of time you have to take the intersection of two subrelations and then it should be behaving as the key. It should determine all the attributes of either of the relation or R2. It should behave as a key for relation R1 or R2. If that is the case, then join R1 and R2. जैसे दो सब रिलेशंस ज्वाइन हो गए बट वी वांट टू जॉइन ऑल द सब रिलेशंस, सो थर्ड स्टेप इज रिपीट step 2 until we get a single relation. मतलब ज्वाइन करते करते आपके पास सिंगल relation आना चाहिए. If at the end we are getting a single relation, then the decomposition is lossless. If more than if it's not possible to get a single relation, then the decomposition is lossy. Okay, if we are getting at the end by following these steps, at the end we are getting a single relation, so we can say that the decomposition is, अगर एक ही relation मिल गया इसका मतलब decomposition is lossless, there is no loss of data. I guess this is going behind the image, that's okay. So let me write here, if that is the case then we can say that decomposition is lossless. Make sense? If these rules are clear, then let's apply these rules on the set of questions so that it gives you more clarity and more confidence. So quickly give me the confirmation. So I have discussed everything about lossy and lossless joint decomposition, various cases in one shot so that we won't face any difficulty while solving the questions. Clear? I guess for clarity, some questions are required. All right. So here it is saying that we have a relation R1 and this is having the attributes. I have already told you that data is not required. First example, may I considered the data in order to just give a proof for the rules that we are going to check for lossy or lossless decomposition. So relation R1 is decomposed into two subrelations. R1 relation R is decomposed into two subrelations R1 and R2. This is the relation R. Okay. So how to check? What are the steps? The very first step is see if it is covering all the attributes R1 union R2. R1 के attributes कौन-कौन से A, B, C and R2 के attributes हैं C, D. C is already covered, so this is returning D. Is it containing all the attributes of the relation R? Yes, so it is covering all the attributes of the relation R. So condition 1 is true. Let's move on to the second condition. Is there any common attribute between R1 and R2? R1 is having the attributes A, B, C. R2 is having the attributes C, D. So common attribute C is the common attribute. So this is not equal to 5. हमने ये बोला था कि there should be some common attribute. So second condition is also true. Third condition is saying that this common attribute should be R1 intersection R2 closure means जो भी common attribute है we have to take its closure. Common attribute is C. Find out C closure. Closure find करने के लिए we need the functional dependency. Functional dependency is given. So C closure, C will be determining itself. C is determining D. So C closure is it determining all the attributes of some relation? If it is going to determine all attributes of either R1 or R2, then it will be a key. So R2 में हमारे पास सिर्फ और सिर्फ दो ही attributes आ रहे हैं, that is C and D. So we can say that C is behaving as a key for R2. Since it is covering all the attributes of the relation R2, so we can say that the common attribute is a key of R2. If common attribute is a key attribute, so we can say that decomposition is lossless. Yes? यही डिस्कस किए अगर हम कॉमन एट्रीब्यूट की एट्रीब्यूट ले रहे हैं तो देयर इज नो लॉस ऑफ डेटा. Clear? So just we have to follow these three steps. There should be some common attribute and that common attribute should be a key attribute, and after joining the relation we should get all the attributes of the original relation R. Correct? I guess this was a very simple example. Let's move on to the next question, but before that, information from your side. Guys, quickly give me the confirmation. Hurry up. Do you want me to take more examples? If yes, then you have to do the interaction. You have to give the response. Hurry up. Guys, after this, we have to discuss one more concept, that is dependency preserving. Hi, Rahul. इस टाइम पे मेरा क्वेश्चन हाई हेलो पे नहीं था. I was asking for the concept clarity. Okay. Next question. Here also the relation R, D is representing the decomposed relation. Okay. So given decomposition, or the relation is decomposed into two sub-relations. R is having the attributes A, B, C, D, E, F, and this relation is decomposed into the sub-relations. R1 is having two attributes B and E. R2 is having the attributes A, C, D, E, F. So can you tell me that here is the first condition true? First condition mein what we are doing is we are taking the union of R1 and R2. Is it covering all the attributes of the original relation R? R1 is having the attributes B and E. R2 is having the attributes A, C, D, E is already covered, and F. So it is covering all the attributes of the relation R. So we can say that first condition is true. Yes? Now check for the second condition. What is the common attribute? Is there any common attribute? R1 intersection R2. Quickly write the answers in the chat section. एक दो questions आप मेरे साथ करोगे उसके बाद independently करोगे. R1 intersection R2. Is there any common attribute between R1 and R2? Yes or no? If there is a common attribute, what is the common attribute between R1 and R2? Okay, so here common attribute is E. Very good. So this is not equal to 5. This means that second condition is also true. Check for the third one. What we need to do is we need to take the closure of the common attribute. Find out E closure and let me know if it is a key attribute or not. Is it a key attribute? Find out E closure. E closure will be determining itself. E is determining itself. Is it determining any other attribute? E और किसी को determine नहीं कर रहा. E is it covering all the attributes of R1? R1 में B E आ रहे हैं, but closure में हमारे पास सिर्फ E आया है. R2 में तो बहुत सारे attributes हैं, so this is non-key. This is not a key attribute. If it is a non-key, that means it is lossy. So we can say that given decomposition is lossy. Correct? Now let's increase the speed. Here also we are given with the relation R which is decomposed into two sub-relations. R having the attributes A, B, C, D, E decomposed into R1 having the attributes A, B, C and R2 having attributes A, C, D, E. So the very first step is take the union. Step 1, R1 union R2. R1 is having the attributes A, B, C. R2 is having the attributes A, C, D, E. So AC is already covered, D, E. So we had 5 attributes only. So it is covering all the attributes of the relation R. So condition 1 is true. If it is true, go to step 2. Is there any common attribute? Yes. A, C are the common attributes. So this is not equal to 5. So this condition is also true. The third step, we have to take the closure of the common attribute. AC is going to determine itself and A is determining B and C. So B will also be taken here. Then anything else? B is determining D. Although आपको check करने की जरूरत है, it should behave as a key for either of the relation. एक के लिए भी ABC आ गया तो R1 के लिए तो है ही. So you can stop here as well. Or if you want to find out the complete closure, you can do that also. But exam में इसका कोई फायदा नहीं है क्योंकि अगर किसी भी एक भी relation के लिए की है तो decomposition is lossless. So A, B, C, D, C, D मिलकर E को determine कर रहे हैं. So definitely AC is a key for R1 and R2 दोनों के लिए ही किए, हमें तो एक के लिए चाहिए था. So If it is a key attribute, then decomposition is lossless. So we can say that the given decomposition is lossless. Confidence आया? So अभी तक हमने जितने examples लिए हैं, in those examples, the relation is decomposed into two sub-relations only. So this is the last example on the same. And after that, we'll be going for the examples where the relation is decomposed into more than two sub-relations. So quickly tell me that whether this decomposition is lossy or lossless. बहुत छोटा सा क्वेश्चन है, बहुत कम फंक्शनल डिपेंडेंसीज गिवन है. So I want the answer in 30 seconds. Orally हो जाएगा I guess ये. Lossless. Okay. So step 1, take the union R1 union R2. देखिए पता चल रहा है it is returning ABC. So yes, first condition is true. Second one, common attribute is A, so it is not equal to phi. A, that is not equal to phi. Some common attribute is there. Find out the A closure. Only one dependency is there, that is going to return AB, and this is behaving as a key for R1. What is this R1? I'm calling this decomposition as R1 and this is R2. So अगर key है तो definitely decomposition is lossless. Very good. So with two sub-relations, this is clear. Let's move on to the question where the relation is decomposed into more than two sub-relations, 1, 2, 3, 4. So इसमें क्या बताया था? We have to follow the same steps till we get a single relation. If at the end we're getting a single relation, so the decomposition is lossless, otherwise it is lossy. Here we are given that the relation R having the attributes A, B, C, D, E, G. This is decomposed into four subrelations, R1 having the attributes AB, R2 having the attributes BC, R3 having the attributes ABDE, R4 having the attributes EG. Okay, so what we need to do is, first of all, we'll find out whether all the attributes are covered or not. So R1 union R2 union R3 union R4, जितने भी सब relations है सबका union लेंगे and we'll see whether it's covering all the attributes AB, then we are getting B and C, then D is also coming, and in 4 G is also there. So all the 6 attributes are covered, so condition 1 is true. Now let's move on to step 2. Take any two subrelations, कौन से दो लेने हैं? It's completely your choice. Take any two subrelations and try to join them. कब join करेंगे? If we are getting the key attribute. So first of all, I'm considering R1 and R2. Intersection R2, we are getting B as the common attribute. So find out B closer now. B closer is B, and B is determining D. That's it. So is it behaving as a key for either of the relation? इन दोनों में से किसी भी relation के लिए key बन रहा है? This is not a key, so we cannot join them. Okay. Let me try with R1 intersection R3. As of now, we have four subrelations. Common attribute between R1 and R3 is AB. Find out AB closer. AB will surely be determining itself AB. And after that, AB is अगर AB को भी determine करे तो this is behaving as a key for R1. तो मैं यहीं पे बोल सकती हूँ कि R1 और R3 को हम join कर सकते हैं because this is a key for R1. But if you want to find out the proper closure, you can. ए बी मिलकर सी को डिटरमाइन कर रहे हैं एंड बी इज डिटरमाइनिंग डी, ए डी मिलकर ई को डिटरमाइन कर रहे हैं एंड ई इज डिटरमाइनिंग जी. सो दिस इज बिहेविंग एज अ की for R1 and R3. So anyways, these two subrelations can be joined. So after joining R1 and 3, we are getting the attributes as A, B, D, E. R2 अभी तक किसी के साथ join नहीं हुआ है. B and C. R4 having the attributes E and G. ये clear हुआ? Join कब करेंगे? When there is a key attribute. So from four subrelations, now we have three subrelations. Now again, we'll repeat the step 2. Step 2 means now again take two subrelations. I'm taking R13 intersection with R4. Is there any common attribute? Yes, common attribute is E. I'll find out E closer. E is determining itself. E is determining G as well. This is behaving as a key for it is determining all the attributes of R4. So we can say that E is a key for R4. That means we can join R134. We'll get here R13. 13 को किसके साथ join कर रहे हैं? 4 के साथ. Attributes क्या होंगे? A, B, C, D. A, B, D, E. These are the attributes of 13 और 4 के attributes है E and G. G. And here we have R2, B and C. Right? Now again we'll try to join these two subrelations. Let us try. So check, are you getting this? So step by step I'm trying to join the subrelations. R2. Common attribute is B. We have already calculated the B closer. What was the B closer? B closer is BD. And this is not a key for either R134, ना तो R134 के सारे attributes आ रहे हैं और ना ही R2 के आ रहे हैं. So this is non-key. If it is non-key, we cannot join it. And since at the end कोई option बची नहीं है, so at the end, not getting a single relation, not getting a single relation. So we can say that the given decomposition is lossy. Okay. So here we can say that given decomposition is lossy. Guys, is this clear? तो दो ही केस बनते हैं, या तो दो सब रिलेशंस में डिवाइड होगा या दो से ज्यादा में होगा. अगर दो है तो just we have to repeat the step 2 only for one time. If it's decomposed into more than two sub relations, then we have to repeat the step 2 till we get a single relation. If at the end we are getting a single relation, so the decomposition is lossless, because this simply indicates that we can join the given relations so that we get the original relation R. But if at the end we are not getting a single relation, that means we cannot join it. Is it clear? So this is about case 2. Clear? So this is all about lossy and lossless decomposition. Second property is dependency preserving. I hope property 1 is clear. No confirmation. नेक्स्ट वन इज वेरी इजी. डिपेंडेंसी प्रिजर्विंग मीन्स कोई भी रिलेशन है जो डिपेंडेंसीज ओरिजिनल रिलेशन आर के लिए एग्जिस्ट कर रही है, all those dependencies should also be holding in the sub relations as well. If it is true, then we will say that the given decomposition is dependency preserving, and if it's false, then we will say that not dependency preserving. Okay, so if the original relation R is decomposed into the sub relations R1 and R2, तो definitely functional dependencies भी divide हो जाएंगी. If the original functional dependency set is F1, तो R1 का अपना कुछ functional dependency set होगा. Let me call this as F1, and for R2 this is F2. Okay. Now what we are saying here, let R be a relational schema decomposed into the sub-relations schema with functional dependency set F, because here we have to consider the functional dependency as well. बच्चे मेरे पास अभी तक कोई रिस्पॉन्स नहीं आया कि लॉसी और लॉसलेस क्लियर हो गए. If you are actually without waiting for your response, why I'm moving on to the next concept, because I want to save the time. But अगर आपको कोई भी doubt आता है तो definitely after discussing the definition of dependency preserving, I'll discuss your query. Okay, relational schema with functional dependency set F is decomposed into relation R is decomposed into sub relations R1, R2, R3 and so on up to Rn with the functional dependency set F1, F2, F3 and so on up to Fn respectively. So in general, what we say is F1 union F2 union F3 and so on. जब सारी functional dependencies को consider करते हैं, then either some of the functional dependencies are lost or it is all preserved. कभी भी extra functional dependencies create नहीं होंगी, या तो कम होंगी या फिर ज्यादा होंगी. If तो यहाँ पे हमारे पास दो cases हैं. If it is preserving all the dependencies, that means equal to Fn, this is equal to F, or other possibility is it is not preserving all the dependencies, so less than F. Some of the functional dependencies are lost. So here, in this case, we will say that it is dependency preserving. If all the dependencies are preserved, so it is dependency preserving, not dependency preserving. Okay. All right. So this is dependency preserving and not dependency preserving. कभी भी ऐसा केस नहीं होगा कि आप जो functional dependency sub relations hold कर रहे हैं, those are more than the original functional dependencies of the relation R. कभी भी extra functional dependencies नहीं आएंगी, या तो कम होंगी या फिर equal होंगी. So that's why in general it is less than or equal to, but can never be greater than. Okay, so this condition can be asked in true or false. Now let's discuss the question how to check whether the dependency is preserved or not. We are given with the original relation R having four attributes. R is having the attributes A, B, C, D, and this is decomposed into the sub-relations A, B, C and C, D. Okay, see, in order to check the functional dependencies, there are two ways. One is with the direct mapping, and other one is you can find out the non-trivial functional dependencies existing in the sub-relations. Okay, सबसे पहले हम direct mapping के साथ करते हैं. There are two methods. First method is Method 1 is with direct mapping, and other one is by finding non-trivial. I have discussed what are trivial dependencies, what are non-trivial functional dependencies. So I hope that this is clear to everyone. So method 1 is saying that consider the first functional dependency, that is A determines B. A determines B is containing two attributes. Simply देखो कि दो attributes आ रहे A B और कौन से सब relation में आ रहे R1 में आ रहे. So this means that A determines B is preserved by R1. B determines C. C R2 में भी आ रहा है, but B और C दोनों किस में आ रहे हैं? R1 में. यानी कि B determines C will be preserved by R1. C determines D. Both the attributes are present in uh, R2. C and D, two attributes are involved in this functional dependency. So C determines D is preserved by R2. This is method 1, that is direct mapping. Direct mapping. Another method is by finding the non-trivial functional dependencies. Non-trivial functional dependencies कैसे find करनी है? Method 2. So I need to check for A determines B. So what we'll do is we'll find out A closer. Okay, A closer in the given functional dependency set is A, B, C, D. In this sub-relation only we have three attributes, so we'll not be considering D. अब यहाँ से देखो non-trivial functional dependency कौन सी होती है? In which there is no common attribute. So यहाँ से non-trivial functional dependencies क्या आ रही हैं? A determines B and A determines C. These are the non-trivial functional dependencies. सारी check करने की जरूरत नहीं है. Just consider the functional dependencies which we need, okay? Or whatever functional dependencies are given in the functional dependency set. B closer find करेंगे. B closer will be B, C, D. इस सब रिलेशन में कौन से एट्रीब्यूट्स आ रहे हैं इनमें से? ओनली बी एंड सी. सो वन नॉन ट्रिवियल फंक्शनल डिपेंडेंसी इज कमिंग अप, दैट इज बी determines C. Then is find out C closer. C closer is CD. So in this case, D is not present. Is there any non-trivial functional dependency coming from starting from the attribute C? No. So these are the three functional dependency, and we're looking for A determines B and B determines C. So these two are preserved by R1. Similarly, we'll check for R2. C closer is CD. In this, we have both the attributes. So one non-trivial functional dependency is coming up. So C determines D is preserved by R2, and first two functional dependencies are preserved by R1. Okay, so this is method 2. By finding the non-trivial functional dependencies, you can check for the functional dependency. Since here all the functional dependencies are preserved by the subrelation, so we can say that given decomposition is dependency preserving. Given decomposition is dependency preserving. Make sense? Is it clear? Just let me give you one more question. First of all, quickly give me the confirmation if it's clear. We'll solve one or two more questions just to get the clarity. So here the relation R is decomposed into the subrelations, three subrelations, R1, R2, and R3. Just see if if the given decomposition is dependency preserving or not. Quickly return the answer. So given relation R, it's up to you how you want to find out whether the decomposition is dependency preserving or not. It's completely your choice. मैंने दोनों methods discuss कर दिए आपके साथ. तो जो भी फंक्शनल डिपेंडेंसीज ऑब्वियसली डायरेक्टली मैप हो रही है उनको तो डायरेक्टली करवा दो. वी नीड नॉट टू वेस्ट आवर टाइम. और जो डिपेंडेंसीज डायरेक्टली प्रिजर्व नहीं हो रही है उनके लिए आप नॉन ट्रिवियल फंक्शनल डिपेंडेंसीज फाइंड आउट करके चेक कर सकते हो. So here the relation R having four attributes A, B, C, D. This is decomposed in the sub-relations R1 having the attributes A, B. This is first decomposition, second and third. R2, B and C, and R3 is also having two attributes C and D. Check for the first functional dependency. A determines B. Is it preserved by relation R1? Yes, A and B two attributes are there, so it is preserved by R1. B determines C. It is preserved here. C determines D. This is preserved here. What about D determines A? So D is an attribute in directly to map nahi ho raha hai, but D is an attribute present in R3. So let me find out D closer. What is D closer? D is determining D, A is determining B, and B is determining C. Here the attribute A and B is missing. So from this we are getting one dependency, that is D determines C. Here, C closer, if I find out C closer, C is determining D, D is determining A, and A is determining B. In this case, A is not present, D is not present. So one non-trivial functional dependency we are getting here is C determines B. B closer is B, C, D, A. Attribute C and D is not a part of the sub-relation R1. So यहाँ पे हमारे पास non-trivial dependency आई, that is B determines C. B determines A. Now, if you see here, these dependencies are directly mapped. Problem किस में आ रही थी? D determines A. If you see here, this is indirectly preserved. Indirectly कैसे? R3 is supporting D determines C. This is supported by R3. C determines B is supported by R2, and B determines A is supported by R1. So indirectly we can say that indirectly D determines C, C determines B, and B determines A. So we can say that indirectly D is determining A. D determines A is preserved. Since all the functional dependencies are preserved, so we can say that answer for this question is given decomposition is dependency preserving. Make sense? So जरूरी नहीं है कि हमेशा आपके पास डायरेक्टली मैप होंगी ही होंगी सारी फंक्शनल डिपेंडेंसीज. That's why I have discussed the second method by finding the non-trivial functional dependencies. Make sense? Clear? So let's move on to the next question. The given relation R is decomposed into three sub-relations. Just try to solve this. Relation R is having the attributes A, B, C, D, E, F, and this is decomposed into three sub-relations: AB, R2, C, D, E, R3, E, F. Quickly write in the chat section that whether the given decomposition is dependency preserving or not. जो डिपेंडेंसीज डायरेक्टली मैप हो रहे हैं उनको डायरेक्टली मैप करवा दो, और जो डायरेक्टली मैप नहीं हो रही है, फॉर दैट try to find out the non-trivial functional dependencies and then check whether the required functional dependency is indirectly mapped or not. Indirectly mapping हो रही है, उसके लिए आपको non-trivial functional dependencies find out करनी पड़ेगी. So first one is AB determines CD. A, B, C, D ये चारों attributes किसी भी एक सब relation में तो नहीं आ रहे, so indirectly we need to check for this. C determines D, both the attributes are a part of the relation R2, so C determines D is directly mapped by R2. D determines E, D and E both are present here, so D determines E, this is also preserved by R2. This is preserved, this is preserved. E determines F, this is preserved by R3, direct mapping. Now for indirect mapping, कहाँ से start करेंगे? AB closer से, because we have to determine CD by AB. So I'll find out AB closer. AB closer is AB. AB is determining CD, D is determining E, E is determining F. AB सिर्फ और सिर्फ R1 में आ रहा है. अब AB के अलावा no other attribute is there. So we are just left with is AB is determining EB. In this case, no non-trivial functional dependency exists. No non-trivial functional dependency exists. और किसी relation में A भी आ नहीं रहा. This means that there is no scope of preserving this dependency. So we can say that AB determines CD is not preserved. Hence, we can say that given decomposition is not dependency preserving. I hope that you all are comfortable with this concept और normalization में कोई problem नहीं आएगी. In case you have guys any doubt, please write that in the chat section, because I'll not be repeating all these concepts while talking about the concept of the normalization. Okay, तो normalization में हम सिर्फ और सिर्फ normalization के concepts use करेंगे, and I'll be assuming that you have covered this topic in depth and you are comfortable with the decomposition. So yeah, you just need to understand this concept. This is the last question from today's session. Just quickly tell me that whether the decomposition is dependency preserving or not. This is the last question. And after that, we'll wrap up our session. Relation R is having the attributes A, B, C, D, E, and G, decomposed into the subrelations. R1 having three attributes A, B, C. R2 is having four attributes A, C, D, E. R3 is having three attributes A, D, G. Now check if it is preserving the dependency or not. First one is AB determines C. All the three attributes are present here, so it is directly mapped in R1. First functional dependency is preserved. AC determines B. AC यहाँ पे भी आ रहा है, यहाँ पे भी आ रहा है. But B is only a part of R1, so we can say that AC determines B is also preserved in R1. AD determines E. AD determines E is preserved in R2. B determines D. B is present here. D is present in R2 or R3. So we need to check it by following non-trivial functional dependencies. BC determines A. It is preserved in R1. E determines G. E is present here. G is present here. This has to be mapped indirectly, right? So if I want to check for E, though E is only a part of R2, so let's find out E closer. E closer is E. E is determining G. G is not a part of R2, so we cannot consider it. So starting from E, there is no non-trivial functional dependency. So this means that this dependency, there is no scope that this dependency can be preserved. You know? And next one is B determines D. B is only a part of the relation R1. So let us find out B closer in R1. B is going to determine itself. इसके अलावा अभी तक सिर्फ attribute B आया है. B is determining D, and that's it. And D is not a part of R1, so there is no non-trivial functional dependency starting from B. So इसका मतलब directly or indirectly we cannot preserve the functional dependency B determines D. Since अगर एक भी आपके पास functional dependency आती है which is not preserved by any of the subrelation, then we say that the decomposition is not preserving the dependency. In fact, इस केस में तो आपके पास दो functional dependencies है जो preserve नहीं हो रही है. So clearly the answer is it's not dependency preserving. So given decomposition is not dependency preserving. Clear? Yes? So this is all about decomposition of a relation. We have seen that decomposition is said to be correct if and only if it is lossless joint decomposition and dependency preserving. We have discussed the rules, the algorithm to check whether the decomposition is lossy or lossless decomposition. दो या दो से ज़्यादा relations में हो सकती है. We have covered all the cases. Dependency preserving के लिए we have discussed the direct mapping and by finding the non-trivial functional dependencies. अगर indirectly भी dependency preserve हो रही है, then also it will work, but at least it should be preserved. If even a single dependency is not preserved in the subrelation, so we can say that the decomposition is not dependency preserving. So this is all about the decomposition of a relation. If anyone is having any doubt, guys, you can ask. Otherwise, this is all from my side. In the beginning, also I told you that I have an official Telegram group, that is Shefali Ma'am Testbook. You can search for it. In order to get the daily PDF of all the YouTube sessions, you can ask your doubts or the queries in this group. You can directly interact with me. You can also participate in the quiz and the poll, right? Apart from that, currently the sale is going on. Tomorrow is the Mother's Day, so Mother's Day sale is going on. तो ये आपके लिए एक benefit लेके आए, that is the discount is going on with the extra validity. Extra validity is like if you are purchasing like 1 year course, 12 months का course purchase करते हो तो आपको 4 months extra मिलेंगे. If you are purchasing 2 year course, that is 24 months, then you will get approximately 8 months extra, right? So that is extra validity. Apart from that, discount is 65% plus 25% plus 33% extra validity. You can get the subscription for 1 year. 1 year means 12 months, but आपको 16 months का subscription 10,799 में मिलेगा, and you will get the maximum benefits when you are going to apply this code, that is Shefali S, Shefali S. Okay, and apart from that, one more good news is there, that is the lucky students can win a smartphone every hour. तो हर घंटे में एक draw होगा in which you can also be there, so you can take the advantage of this. Let me show you, let me share my screen and show you that how you can uh, go for the link to the Telegram group. I hope that my screen is visible, right? So currently this video is going on. Oh, great. So जो भी बेटा session देख रहे हैं, those who are following the session and you are liking the session, don't forget to like the session and subscribe the channel to get more videos. And जो आपके comments होते हैं, it really motivate me a lot. So don't forget to like the video and give your valuable feedback. So here we have the first link. This is for the master class. So from Monday onwards, we will be having the master classes at 8 p.m. And NIC super coaching जो लोग NIC पे focus कर रहे हैं, but my suggestion is if you have prepared for the GATE exam तो NIC ISRO DRDO ये कुछ भी नहीं है, easily आपका more than 60% syllabus will be covered and काफी important questions भी cover हो जाएंगे. So I'll suggest you to at least prepare for the GATE exam. And here we have the link for the GATE super coaching. And this is the link for the Telegram group. This is my Telegram group. And second one is the link for the super coaching. So super coaching के benefits हैं, you will get the series, you will get the recorded sessions from multiple teachers because every faculty is having the different way of teaching और हर एक स्टूडेंट का अंडरस्टैंडिंग लेवल भी डिफरेंट होता है सो इट्स अप टू यू कि आपको कौन सा बेटर लगता है यू कैन डाउनलोड द ब्रोशर एज वेल टू गेट more information so that before purchasing the course आपके पास एक confidence हो है ना कि आप क्या purchase कर रहे हो क्यों pay कर रहे हो and here is the list of the super teachers. You can see the profile of the teachers. Demo classes are there, live series, mock tests, and study notes are there. So, जो series है, if I go to the courses, here you can see all courses are there, full course and subject-wise courses there. So all courses it's a combination of full courses and the subject courses. I'm directly going to the full course. So full courses provided by the GATE forum and its rating is 4.8, Digimentor rating is 4.8, Nimbus rating is 4.8, and you can see the course, a complete course which is provided by me and my team. You can see the rating is 4.9. So I guess 5 may say 4.8 or 4.9 is really, really very good. So this is the rating which is given by the students. So you can follow the sessions of any faculty. एक faculty से एक topic समझ में नहीं आया दूसरे faculty के sessions देख लो तो कब तक आप sessions देखोगे और every faculty is taking the different set of questions so you will get lot many questions. You can download the course curriculum and you can view the full course as well. And here are the reasons why you why you can choose for GATE CSE super coaching. So here are the demo classes available. You can follow the demo classes. You can follow the series here. So it's there. Okay. So currently many offers are going on, and in order to take the advantage, to take the benefit of this, you can utilize these 2, 3 sale days. And here you can see we have 3 plans. One is the 3-year plan. 3-year plan में आपको 12 months extra मिल रहा है, basically 4 years हो जाएगा. तो this is going to be very very useful and beneficial for the first year students. Second year students के लिए this plan 2-year plan will be really good because approximately you will be getting 32 months. Okay, 24 months plus 8 months extra in just 16,874 and 16-month subscription is beneficial for the students, those who are currently in the third year or fourth year of BTech or those who are pass out. So you just have to pay 10,799. Okay, so this is about the super coaching plans. Anyone having any doubt? So this is all from my side. If you have guys any doubt or query, please write that in the chat section. Otherwise, we are going to end our discussion here. So tomorrow also I'll be taking one more marathon session on solving the reconciliation. My goal is to first of all cover the concepts of DBMS and algorithms, and then we'll be taking the next set of equations. Okay, next subjects. So solving the reconciliation, we know that there are three methods. So in tomorrow's session, we'll discuss the concept of substitution method. We'll talk about recursive tree method and Master's theorem. So if time permits, I'll also talk about the extended Master's theorem. Otherwise, we'll just talk about the basics of Master's theorem. So this will be the agenda for tomorrow's session. So this is all from my side. Anyone having any doubt or query? If no query is there, at least write in the chat section that there is no query so that I can end our discussion. I hope today's session was useful for you guys. So guys, don't forget to subscribe to the channel and like the video. Okay. I guess no queries are there. So this is all about this session. Thank you so much, guys. God bless you. Enjoy your evening. I'll see you tomorrow at the same time. And Monday onwards, we'll be having the master classes as well. So first master class will be on normalization, in which I'll be discussing the previous year gate questions of normalization. This is because on Monday in the YT session, we will be covering the concept of normalization and master में हम PYQs करेंगे. So this will be the pattern. Daily will be having two sessions from Monday onwards, one on YouTube. YouTube में हम लोग concept discuss करेंगे and master class में will be solving the previous year gate questions. And previous year gate questions solve करने की suggestion मैंने NIC batch में भी दी थी. So this will be the best time for you guys to solve the previous year questions. Okay, and live masterclass will be at 8 p.m. and this session, YT session, will be at 4 p.m. Let me write here for you guys. YouTube session timing is daily from 4 p.m. and masterclass at 8 p.m. This is the schedule for Monday to Friday. Okay, and now question arises is that these master classes are on Testbook platform. So is it paid or not? No, this is not paid. So YT sessions are free. Anyone can attend these sessions. Master classes are also free. You need not to pay anything for the master classes as well. So you can take up these classes. In the YT sessions, I'll be just covering the concepts, and previous year questions will be covered in the master classes. Basically, master class is for the practice and covering the previous year questions. So you can note the timings and accordingly you can prepare your schedule. Okay. So thank you guys. Bye bye.